Hi, and welcome to our second algebra lesson, lesson 1.2, exponents and powers. So today, obviously, we're looking at the concepts of exponents and powers, which are defined in these first couple of sentences. So first off, the mathematical expression, such as 4 to the 6th power, overall, that's how we read this, 4 to the 6th power. This whole expression, 4 with a small 6, is referred to altogether as a power. The exponent is the smaller number that's to the upper right, which in this case would be 6. And then the bigger number down to the left is called the base. So in our example of this power, 4 would be the base and 6 would be the exponent. Now, the way that a power works is the exponent tells us how many times we need to multiply the base by itself. So 4 to the 6th power means we need to multiply 4 by itself 6 times. So 4 to the 6th power would be 4 times 4 times 4 times 4 times 4 times 4. So the exponent tells us how many times to multiply the base by itself. So 2 additional examples over here to the right. If I have 3 to the 5th power, my base is 3, 5 is my exponent, so I'm going to multiply the base 3 by itself 5 times. So that would be 3 times 3 times 3 times 3 times 3. And 7 to the 3rd power is not 7 times 3 being 21. That means 3 times we need to multiply 7 by itself. So that would be 7 multiplied by 7 multiplied by 7. So, example 1 is just expressing the meaning of the powers in words and then with numbers or variables. So we're looking at A through E here. They give us the exponential form. So they're giving us the expression. First, they want us in the first column to write what that means in words. Then the meaning of it, the mathematical meaning, you'll see in this far right column. So 10 as a base, exponent of 1, we would read that as 10 to the 1st power. And what that means is simply the number 10. In part B, we have a base of 4, an exponent of 2. So anything with an exponent of 2 can be called squared. So one way to read this would be 4 squared, or we could read this as 4 to the 2nd power. So it's 4 squared or 4 to the 2nd power. Anything to an exponent of 3 is cubed. So this could be read as 5 cubed or 5 to the 3rd power. And then our far right column, 4 squared, on the previous one meant 4 times 4, so we're going to skip that before. And for C, with 5 cubed, it means mathematically it's 5 times 5 times 5. In D, we have a base of 7, an exponent of 6, so we would simply read that as 7 to the 6th power. And what that means mathematically is 7 times 7 times 7 times 7 times 7 times 7. So we should have 7 being multiplied 6 times. And then in E, we have a base of a variable of x and an exponent of a variable of n. So we would read that as our base x to the nth power. And what that would mean is x times itself n number of times. power is up here, that would tell us how many times to multiply x by itself. So example 2, they ask us to evaluate the expression x cubed, or x to the third power, when x equals 5. So evaluate means to solve or simplify. So x to the third power will replace x with 5. So what that means is 5 times 5 times 5. 5 times 5 is 25, multiplied by 5 again, gives us our final answer of 125. Then we need to understand the idea of grouping symbols, which help us know what order to do the mathematics and when we can apply the exponent or power. So in the past, you may have learned the order of operations using the acronym PEMDAS, or please excuse my dear Aunt Sally, something similar to that. And what that stood for was parentheses, exponents, multiplication, division, addition, subtraction. Now that you're in high school and in algebra, I would teach you, instead of PEMDAS, the phrase GEMDAS. So instead of starting with parentheses, it starts with a G, which stands for grouping symbols. And as we read through these few sentences, you'll see why. So for problems that have more than one operation, we know we have to use the order of operations. So grouping symbols tells us which operation to do first. So grouping symbols such as parentheses or brackets indicate the order in which operations should be performed. Operations within the innermost set of grouping symbols are done first. So we have to do any operations inside the grouping symbols first. So for instance, if we were looking at this expression, 3 times 4 in parentheses plus 7, that would not give us the same value as 3 times, and then in parentheses 4 plus 7. So the grouping symbols tell us which operation to do first. And if there's more than one set of grouping symbols, you work your way from innermost to the outside. And we'll take a look at quite a few of those examples as the year goes. So our 2 examples here. This one on the left, because the 3 multiplied by 4 is inside our parentheses, we have to multiply and then add the additional 7. So 3 times 4 gave us 12, 12 plus 7 gave us 19. In our second example, the 4 plus 7 is in parentheses, so we have to do that first, and then we can multiply by the 3. So our final answer there would be 33. So with grouping symbols, you need to make sure that you're following the order of operations and doing what's inside the symbols first. Now a couple more practices with the grouping symbol idea. They're found here in example 3. So in example 3, they say evaluate the expression when A is 1, A equals 1, and B is 2. Equals 2. So I'm going to replace A with 1 and B with 2 before I solve these. So our first one in A is parentheses around A plus B to the second power. So I replace A and B with 1 and 2. And before I do my exponent, I have to do the addition inside the parentheses. So this would be 3 to the second power, which means 3 times 3, or 9. In part B, it's still A squared and B squared, but now they're each in their own set of parentheses. So what that tells me is I have to do the power first, or the exponent, before adding. So our A squared is 1 squared, B squared is 2 squared, which gives us 1 plus 4. And 1 plus plus 4 gives us a final answer of 5. So you can see how using grouping symbols can change the final answer that you get, even if you're plugging in the same values. And then example 4 asks us to evaluate the expression when x equals 4. So in both part A and B here, we'll be replacing x with 4 and then solving. So 2 times x to the third power. That would become 2 times 4 to the third power. Now, if we're following the order of operations, we don't have any grouping symbols. So exponents come before multiplication. So I need to take care of my 4 to the third power before I multiply by 2. So 4 to the third power is 4 times 4, which is 16, times 4 more, which is 64. And then to get our final answer, 64 times 2 is 128. In part B, it's also 2x to the third power, but in this case, the 2 multiplied by x is in parentheses, so we have to do that first. So our setup would be 2 times x in parentheses to the third, x gets replaced by 4, 2 times 4 is 8, so then our final answer would be 8 to the third power, 8 times 8 times 8, which is 512. Now our next piece is just helping you understand where those terms squared and cubed come from. So exponents, and you'll see this when you get to geometry, exponents are often used in the formulas for area and volume. In fact, the words squared and cubed come from the formula for the area of a square and the volume of a cube. So to find the area of any squared, it's the side to the second power. So that's why we always call anything to the second power squared. It's how we find the area of a square. For volume of a cube, it's any of the sides to the third power. So that's why we call anything to the third power, or exponent of 3, cubed. So that's just an explanation of those two special terms. And then we get to our final example for today. Obviously a word problem with a picture. So they tell us the aquarium has a shape of a cube. Each of the edges is 2.5 feet long. So 2.5 wide, 2.5 deep, and 2.5 tall. So the first part asks us, find the volume in cubic feet. So I'm going to use my volume formula for a cube, which is side to the third power. So volume equals our side to the third power. Our side is 2.5. So to get our answer, we have 2.5 to the third power, which is 15.625 cubic feet, or feet cubed. And then in part B, they're asking us how many gallons of water will the cubic aquarium hold? Convert to liquid volume, where 1 cubic foot holds 7.48 gallons. So if I had 1 cubic foot large aquarium, it would hold 7.48 gallons. But we have a 15.625 cubic foot aquarium. So we need to multiply by the 7.48 gallons. So 15.625 multiplied by 7.48 gallons. And this aquarium would hold approximately 116.875 gallons of water. So as we work through today's practice problems, the biggest concept to make sure you understand is way back here at the top, the idea of a base, an exponent, and how we can evaluate or use powers. And we're going to keep coming back to the idea of exponents and powers throughout algebra this year. So if you don't understand anything from the notes or you're struggling on the practice problems, remember you can ask peers or classmates for help as need be, as long as you stay on task, or I highly encourage you to obviously ask me for help, and I can clear up any